So in the last video, we had briefly discussed what functions, intuitively what functions are, and how sine functions can be described from in terms of a unit circle. So it is basically the the length of perpendicular drawn from um, the ray that forms the your angle, which is x, onto the base, onto the horizontal base. So actually, this unit circle is defined in a coordinate axis. Coordinate axis is basically just a moment. Coordinate axis is basically two mutually perpendicular, infinitely expanding rays, extending rays. So you have y o y dash, and then you have x o x dash. So this line, this ray goes from 0 all the way to infinity. So, well, and this line, this OX dash ray, it goes from 0 to minus infinity. So your number line, if you are familiar with number line, so all the numbers that, all the real numbers that we know can be found on x dash ox or x o x dash. All the numbers lie on this line, and another number line is set mutually perpendicular to x o x dash, which is the y. And when I was introducing functions, I had said that y is the output and x is the input. So you see, all the coordinates, any coordinate in this in this plane of on this plane of paper is uniquely categorized by 2 points, that is x and y. What is x? X is the distance. It is the distance of O. Let's say this point B. I'll draw. This is point A, and what is unique about point A is that the identity, the location of point A in this plane is categorized by xy. Okay. So this distance, you draw perpendicular onto x o x dash. Now this distance OB is actually x, and this length of perpendicular AB is y. So any point, let's say I close my eyes and randomly mark a point here, right? Now this point will also be categorized by some coordinates x dash, y dash. And what does this x dash, y dash means from the definition that we have established is that when you draw a perpendicular onto x o x dash and connect the origin with it, then this length is actually y dash, and this length all the way from O to here is actually x dash, right? So in our coordinate axis, I'll superimpose the unit circle. Right? And what was unique about this unit circle? It was the fact that the radius is 1, right? It is of unit radius. So let's say this angle be x, right? This angle be x. Then we had established that this AB is actually sine x in the unit circle. And what is AB? From the discussion on basic coordinate geometry that we have established, AB is simply the y coordinate of the point A. So if A is characterized in this plane by x and y, then y is actually sine theta. Or let's make it much more clearer, is that if A is characterized by 2 points, let's say 2 and 3, right? This be the coordinates on 2 and 3, and it lies on the unit circle. That is essential, right? Unit circle is essential for the y coordinate to be equal to the sine of the degree of rotation from the x-axis. In any general point, in the above point here, let's say this point be P. Now in this case, this y dash is not equal to sine theta. It is only equal when you have a unit circle, right? Anyways, so what I want to say is that if A is demarcated by the points 2 and 3, then the sine x is equal to 3. And later we will see that cos x is equal to 2. And tan x is simply the ratio of the two, which is 3/2. Whether these numbers are valid or such a point actually exists or not is not relevant. What is important is that y coordinate of a point lying on the unit circle is equal to the sine of the degree of rotation from the x-axis. I had also restricted the value of x between these two from 0 to 90 degree. So for in this quadrant as such, I'll take a let's say this pink color. Now in this quadrant, for any degree of rotation x, the value of sine x is equal to the y coordinate of the point on the circle, right? So when you draw the graph of this function sine x, you will find that between 0 to pi by 2 is nothing but 90 degree, y and x. You have y is equal to sine x. Now the graph of this function goes from 0 to 90 degree. Right. Now also let's further expand this, that for, let's say, I'll take a so what you have discussed at this point is that coordinate geometry and unit circle, the correlation. Now for a brief moment, I want you to imagine this. This is a unit circle, right? And this is with the I divided into 4 quadrants, as you can see in this case. There are 2 quadrants. There are 4 quadrants: 1, 2, 3, and 4. Right? So these are the 4 quadrants. Now consider a point A. Consider a point A, which is denoted by x and y, and another point as A dash as minus x comma y. Yet another point A double dash with the coordinates minus x minus y, and another point as A triple dash as x comma minus y. You know, minus only indicates the direction in a coordinate axis. A minus x direction, minus 2, is simply to the left of the origin, 2 units to the left of the origin, whereas plus 2 is simply 2 units to the positive side of the origin. Yet the magnitude of the distance, the length of that base remains the same. Distance doesn't change. Negative is only indicative of the direction. So whatever be the case in this unit circle, you will observe a graph or some form of this form when you draw them. And without talking about congruency or similarity, you can see that all the four triangles are equal just by looking at the symmetry and the way we have constructed it. These distances, that is b double dash, well, it doesn't make sense to explicitly write b double dash because we are referring to the same point, but just for the sake of our convenience, actually it's mathematically wrong, so I'll just remove it. So what I mean to say is that this be centered at O, so OB is equal to OB dash. OB dash is indicated by minus x, but it's just the direction. The absolute distance remains the same. So you observe that when the magnitude of the sign, I've said that in a unit circle, the y coordinate of the point is indicative of the sign of that value. So for point A, but we haven't discussed what is the input in this case. We have already moved on to the outputs. So the input in the first triangle is this value x. In the second triangle, this is x dash. In the third triangle, you have this as x double dash, and so on and so forth. And in the last triangle, you have this as the input. So an important or a very symmetrical visualization or a symmetrical theorem, rather not even a theorem, an observation of some sort, is that remark is that for in a unit circle, or rather for different angles, the absolute value, what I mean by the absolute value is that you remove the negative sign. In mathematical terms, we call it the modulus. The modulus of multiple angles in a multiple angles, specifically 4, it's limited to 4 actually, of 4 angles in a in an unit circle are equal. Right? What I mean by that is that what is the value of sin x? It is y. What is the value of sin x dash? It is y. Just pick out the y coordinate. Sin x double dash, it is minus y. And for sin x triple dash, it is again minus y. But you take the absolute value. That is, if sin x double dash is minus 2, then I'll just focus on the number rather than the sign. So the absolute value remains the same. The modulus is typically denoted by 2 bars. This is modulus x. Let's have used x way too frequently. So this is modulus of k. This is how you denote it. So what I mean to say is that from this remark is that mod of sin x is equal to mod of sin x dash is equal to mod of sin x double dash, which is equal to mod of sin x triple dash. So now in this graph actually I can extend to more angles. You see this value in a straight line, this angle is actually pi, 180 degrees, and this entire angle is 360 degrees, which is 2 pi. So I can draw now the curve. Okay, I'll just draw it here. I can extend the sine function from all the way to 2 pi. So you have pi by 2. This is the first quadrant. First quadrant. This is the second quadrant, this is the third quadrant, and this is the fourth quadrant. I should have used the spaces more judiciously. So this is the second quadrant, this is the third quadrant, and this is the fourth quadrant, right? So you have pi, this is pi, this is 3 pi by 2 or 270 degrees. You can dwell deeper and actually look into it. And this is 2 pi, you complete a full circle. So what I've said is that from sin 0 to pi by 2, we have established this curve. Between pi by 2 to pi, sine, the value remains the same. That is, if this is a, then you have another value a dash here. Very symmetrical. So you have this. So it actually forms a sort of a semicircle, right? And between pi to 3 pi by 2, you have minus y. So a double dash is somewhere here, a double dash. And from 3 pi by 2 pi, it goes back up. So a wave of some form you get. It might be intimidating at first because there are many new things that you are unfamiliar with. That is functions, then there is real numbers, then there is coordinate geometry, and then there is points expressed in the coordinate, how the points are expressed in coordinate geometry. There is unit circle, and then also I introduced the notion of modulus, and visualization of this form, of this wave, is also very difficult to comprehend. So I'll urge you to rewatch this video multiple times in order to be familiar with how these things are denoted. And and I would say that it's not the lack of some concept that's stopping you from visualization of this. It's just the lack of familiarity. If I had introduced you this concept in a higher class, you would still have the same difficulty, again due to the fact that it's a lack of familiarity, not mathematical knowledge. So I'll stop it here, and in the next video we will uh, try to establish cos as a function, tan as a function, and see how their graphs are.